8th graders, today's lesson is 3.5 magnetism. So we're kind of shifting our focus a little bit to kind of tie in those theories that we've been talking about of electricity and magnetism and why they're so closely related. So we're going to be focusing in a lot on electromagnets. So your lesson learning targets for today are I can explain how an electromagnet produces a magnetic field, which is something you guys are going to be observing in class with lab as well. And I can explain how energy changes when magnets are moved against and with magnetic fields of electromagnets. So that's really the focus that we've had lately about magnets is if we move something with or against its magnetic force, what does that do to the potential energy or the kinetic energy of that system? Same thing with electromagnets. We're going to kind of be able to observe how that's similar and how that might be different. All right, so by now you should have already completed slides 2 and 3. So for slide 2, you should have added electromagnet into your notes. So an electromagnet is a type of magnet in which a magnetic field is produced by an electric current. So there is a picture attached to that that shows an electromagnet. That should have gone into your OneNote under your magnetism section in your vocab page. And then you should have already completed also the warm-up. So here's a picture of an electromagnet. You should have watched this video, how electromagnets work. That looks something like that. And your main focus for that video should have been how electromagnets are similar to other magnets and how they're different from other magnets. Okay, so you should have answered those two questions, which brings us to slide 4. I just want to double check that you guys are all on the same color group or on the correct color group. So you guys, if you're watching this video, should be my purple group. If you haven't already double checked, you need to right click this link here and open that link up, and then it'll pull you guys into Amplify. You're not doing anything with this in Amplify, you're just checking to say, hey look, I am the purple group. Okay, if you're seeing a color other than purple here, you are not the purple group, and you either need to go back and change videos and do blue group or green group. Okay, so your videos are there at the bottom. Okay, make sure you guys circle your color group so I know which ones I'm grading. And then let's just focus on what you guys are doing for your purple group activities. So in addition to completing slides 2 and 3, which again you should have already done, you guys will be completing the purple color-coded slides on slides 26 through 32. And then finally 33 is your wrap-up that everyone is completing. So let's just go ahead and take a look at what those look like. So we're skipping blue, we're skipping green, we're going right to purple, which is slide 26. Okay, so 26 through 32 is your guys' assignment for today and tomorrow. This is a 2-day assignment. And then also doing your wrap up on slide 33. All right, let's go ahead and get started with your guys' first activity outside of the warm-up today and the notes. So activity 3 is your simulation. What you guys will do in this simulation is you guys will be presented with a situation. In this case, you have 2 setups. And you guys are going to make a prediction about that setup, and then you guys will test it in the sim, collect data, and then compare your guys' data to your actual predictions that you made. So this first slide for today is your predictions. Okay. You guys have setup 1 where we have an electromagnet and then a bar of iron. Okay. So that bar of iron is located 1, 2, 3, 4 grid points away. And then we have the exact same setup where that bar of iron is 4 grid points away, but it is flipped 180 degrees. So we basically just taken and flipped the way the magnet is. Okay, let me just fix this one thing really quick. All right, so again, we've just taken that bar magnet and, or excuse me, electromagnet and flipped it 180 degrees. All right, so you guys will make your first predictions. For setup 1, when we hit run on the simulation, do you think this bar of iron is going to move towards the electromagnet, or do you think it's going to move away from the electromagnet? Okay, based on what you answer for that, whether you think it's going to move toward or away, you guys are going to tell me how you can make the potential energy as high as possible. Remember, this kind of checks back in with us and when we've been talking about moving with or against a magnetic field. So if you think it's going to move toward, okay, that's the way it naturally wants to move. So which way would we want to increase, move that bar magnet to, or excuse me, or that piece of iron to increase the potential energy? And if you think it moves away, okay, which way is going to increase the potential energy? So tell me a little bit about how you guys would move that piece of iron to increase or decrease. Setup 2, same thing, except we've taken this electromagnet and we've flipped it 90 or 180 degrees. So now we are oriented the opposite way. So do you think that iron's going to move towards it, or do you think it's going to move away from it? And again, depending on whether you wrote toward or away, is that going to be, how are we going to change its potential energy? So are we going to move it closer, or are we going to move it further away to maximize our potential energy? All right, let's test this out. So I'm not going to show you guys the results for this. You guys will need to figure that out on your own. You obviously need to right-click your sim down here to launch it. And then you guys are going to go up here, upper left-hand corner, these 3 horizontal lines. We're going to choose electromagnets, and we're going to load our electromagnets mode. We're going to select electromagnet A. Notice how I'm dragging it, specifically how it was arranged in the tools. That's what it means in the directions when it says, in build, create setup 1, electromagnet A should be placed vertically and not rotated. Basically, it should be placed the exact same way you see it in this little toolbox right there. See, our electricity is on. If we turn it off, we lose our magnetic field, and we also lose the color in those coils. So we're going to keep our electricity on. And you guys should also have your field lines on up here. Okay? So there is our electromagnet. We're going to lock it in place. And let's go back and check. All right, now we're going to set up our iron bar. We're going to hit run, and we're going to observe the motion of the iron. So here's our iron bar, 1, 2, 3, 4 points away. Hit run, and you guys will see which way, whether it's going to move toward or away this electromagnet. So you guys will record your data right here. So did it move towards or away? Then I want you guys to mess with the distance and what your potential energy looks like back and forth from that. Okay, so if we move it towards or away, which one has the highest potential energy? So how would you guys move it to maximize that potential energy? So what did you do to make the potential energy as high as possible in the magnetic field? Set up the same thing for setup 2. So you guys will get rid of your electromagnet. You guys will grab a new one, and then you guys will rotate it. Okay, lock that electromagnet in place. And again, do the exact same thing. Run and analyze and see what happens to that bar of iron. Mess with the distance from the electromagnet to try to make it the highest you can. And then answer how you guys made it the highest. Okay? Moving on, your next activity, too far, is a little reading. So it says reading about magnets and iron. Obviously, you guys will not be able to discuss this with a partner, so you guys can just kind of ignore this part right up here. If you place a piece of iron near a magnet, which you guys just did, the magnet will attract the iron. Why does this happen? Strong magnetic fields can create new magnetic fields in some materials, including iron. When the iron is inside a magnetic field, the field creates a north pole and a south pole in the iron. This is what we call a temporary magnet. So you guys will be seeing this a lot in class, where you guys have taken something that's not normally magnetic, like a piece of iron, and you guys have made a temporary magnet. Basically, you guys have realigned it to have a north pole and a south pole. The magnetic poles in the iron align with the poles of the magnet so that the iron and magnet attract. These new poles are temporary. However, if you move the iron away from the magnet, the iron quickly becomes a non-magnet again. So again, it's temporary magnet because it doesn't last. Okay, if we're looking at an electromagnet, we make a temporary magnet out of that nail. Okay, if we have a magnet and a piece of iron stuck to it, we've made a temporary magnet out of that iron. We could take that system and use the iron to pick up other things as well. Okay. All right, moving on from that, you guys have this little image here. It says, check out the diagram on the left, then answer the question on the next slide. So I want you guys to really notice what's different about this electromagnet than what you guys saw in your other slides. Oops. Okay, so take a look at your electromagnet. What's different about it? What do you guys notice that's different? And then you guys have your your iron over here. Okay, there's a piece of iron near a locked electromagnet with the electricity turned off. What will happen to the piece of iron when the electricity is turned on, and why? Okay, so answer that question. Think about what you guys just read as well. And then finally, use the vocabulary in the word bank to explain why a magnet will never repel a piece of iron. So you guys should have seen in that simulation that it didn't move either, it only moved towards, okay? If you flip the electromagnet around, it still sucked that piece of iron into it. Okay, so why will it never repel a piece of iron? Think about how a piece of iron is different than a magnet. And make sure you guys are using these words right here. So magnetic field, magnetic force, magnetic pole, potential and kinetic energy. Okay? Last but not least, that was your last purple coded slide, but you guys still do have your wrap up. So do you have any questions? Circle yes or no. If you have a question, type it right here. Obviously, if it's something that's preventing you from completing this assignment, you guys need to send me a message, let me know in Teams. And then finally, 4, 3, 2, 1, how do you feel you did on this assignment? Okay, let me know. And then last thing I want you guys to do is go back to slide number 4. Double check that you guys have completed everything. Did you do slides 2, slides 3, 26 through 32, and slide 33? Once you've done that, you guys can go ahead and hand in your assignment and have a wonderful day. I'll talk to you soon.